In this video, I'm sharing a solution I've come up with just in case it's useful to others in the Power BI community. For years, I've used a little sandbox file to help me test out like potential solutions when I'm answering questions in the community to help people, but also to keep my M and DAX sharp if I'm doing demos or to conduct experiments to increase my own understanding of DAX and modeling. Lately, I've been helping people troubleshoot performance issues at a larger scale, and so I needed to upgrade what I refer to as my play-taset for doing that type of work. And what I come up with, I thought I'd share here in case it's useful to others. So what I'll share in a minute is basically a scalable and fully self-contained PBIT file that anyone can use to quickly generate a data set of just about any size. So far, I've used it to just over 1 billion rows, but it could be used to go bigger. The nice thing is there's no data source needed. Everything's already hard coded in Power Query, or most of it is generated within the query editor itself. And you can change the scale by changing one or more of four parameter inputs. And then to go really big, you publish it and use incremental refresh to create a big data set. In a minute, I'll show you where you can download it from my GitHub site. And a link to that will also be in the YouTube description below. And this is the first version of this. And so I welcome any feedback. I think these kinds of things are useful to help people have a way to play around or do demos or teach others. So I'd like to make it better, and maybe others will make other playdasets that will be even more useful on other topics. So let me just give a quick walkthrough of it. I couldn't come up with a better name, so I'm calling it the PQE for now, for Power Query everything. And again, if these videos are useful to you, please go ahead and hit the subscribe button. So let me just show it real quick. Let me just show where to download it first. So if you just go to the Hoosier BI GitHub, there's a file share repository, and then there's a play-taset folder, and it's my first file there, so it's just this pqe1.pbit. All right, you download that. It's a few hundred kilobytes, and then you'll input the parameters, and then can start playing with it. Just to show you what it looks like, this is over a small range, so it's not very interesting like this, but when you do it over multiple years, it does look a little more interesting. This one here just has 123,000 rows, 56 products, 4 stores. This uses the Contoso products, so those will look familiar. And I also use just some city data just to give store locations. It also has longitude, latitude in case you want to try out map visuals, etc. And if you look at the data model, real simple star schema, date, stores, and products. The date is a DAX table, but there's also an M version on the query side that you can use if you prefer, and delete this one. But again, real simple star schema and quickly scalable by looking at the parameters. So if you just go up to, well, when you open the PBIT file, basically you'll get prompted to enter one of these 4 parameters. And so you put in the max store count, the max product count, and if you hover over the information here, you can see stores can be up to 3,000, products can be 2,517, which is the full list of the Contoso products, I think. And then you put the input, the start date, and then you put a day later than the desired end date. That's for incremental refresh, so you don't get the duplicate rows between partitions there. And so you put that in, and then you create the data set. I did make 3 of these so far. I have some planned work to do some stuff at scale. And so just to give you an example, I put in these 3 sets of parameters to get these actual values here. And I've put those just up here on my RBI demo tenant, and I've got these 3 data sets, and so I've got 100,000, 10 million, and 1 billion. And if I just click on the big one here, you can see what that summary page looks like at a larger scale. And so you can see here, you can see the trend of all the products sort of have launch dates and discontinued dates, and those are randomly generated, but now they're sort of constants in the data. And then the cities, the stores, there's one in each of these cities, has open dates and close dates. And so this is sort of the growth of the company while products are getting launched and stores are getting opened. And then you see the decline of it in the later years as products get discontinued and stores close. Okay. So let's maybe jump over to the description thing here just to say a little bit more about how it works, and then I'll jump to the Power Query side to do that. I think I've mentioned that. The star schema, oops, this is a typo. I originally had it with AdventureWorks, but now it's Contoso. But these are hard-coded in there, and you can, the category and subcategory are already merged in, so you can test out hierarchy stuff in the model. I also added, along with the launch discontinued dates, I also added a return rate so that a subset of the sales also have a return date populated for when people returned the product. Stores are based on city data. I mentioned the DAX table. There's also a date one, so I use this when answering questions. So sometimes I need to test out something on the M side. So even if I don't load the table, I may do custom columns on the M side and with the date table to test something out. But you can load that if you prefer. Both of the date tables leverage the no sort approach that I've described in a previous blog. I'll drop that link in the description below as well, but this makes it so you can have a date table and not need to sort the date. It uses zero width spaces to avoid that without a sort by column. And basically the fact table is generated by the cross join of products, stores, and dates, considering the open close dates and launch discontinued dates. The quantities are generated randomly, and I say that in quotes because I use the list.random function with the seed parameter, which gives you a random number, but it always gives you the same random number. And so with this, if you put in the same parameter values, you get the exact same data back, which may be useful if you're doing demos, so that or teaching the people following along see the same numbers as you. Again, a small subset, have return dates in case you want to do returns kind of analysis. And then to make the data more interesting, if it's all random at large volume, everything sort of looks the same. So I also put in these volume adjustment factors for both stores and products, so that a subset of data is then filtered back out of the data set so that you see differences between stores and products. Mention list.random. That the reason the two parameters are max store and max product is because of that filtering. It's an upper limit, and some of them may be completely deleted, and therefore you'd have fewer stores and products. And again, the dates are input with range start and range end parameters, which, if you're familiar with incremental refresh, those are the names you need to enable that in the service. So you don't need to use incremental refresh to use this. You can put in whatever date range you want. But if you want to, you can create it very small locally, publish that with incremental refresh, and then let it refresh. The billion row one that I did took about an hour 45. And one note is I did sometimes see a memory issue when I had year level partitions. So I've just been using quarters. So I go back 10 years. So I use 40 quarters. And I haven't had a memory issue when I use it at the quarter level. There's a measures table there with some basic measures, but hopefully you'll add more. And I already showed you the summary page that shows that. A little more about sort of what I personally plan to do with this. Again, I will switch to using this when I'm answering community questions on Power BI. I have, simple one-off DAX and model experiments, but I'm also planning a new series. Jokingly, I'm thinking about it like the bad practices analyzer. But we've all heard of how important it is to follow some of these best practices. And I'm an analytical chemist by training, so I kind of want to measure for my own knowledge, but plan to share with others. Does it really matter when does it matter and how much does it matter, right? And I plan to use those 3 data sets as a starting point to go, hey, this only matters when you get above, a million rows, or this is only important at a billion row scale type of thing. There's going to be a lot of it depends on these, but again, it's how much can it matter is really what the series will be about. And I have other ones planned, but I'm going to start with these, and we'll see if I do more beyond that. I may also do some topics on M or report design. And then again, because this is all hard coded or generated M, this really doesn't help you from learning more about sources and gateways, which of course are critical. But again, you can still do a lot just from the DAX and modeling side. And I sometimes complain, that a lot of the content that out there is all around sales data. But there's other industries as well. And so I'm thinking about, one for manufacturing, one for finance, one for HR, et cetera, or maybe someone else will make those with a similar approach. So I'll just jump over to the query editor just to give a little more about how this works. If you don't want to watch this part, you can stop and just go get the file and start playing. I originally brought in the stores data from a CSV file and the Contoso from the local database on my computer. You can actually delete this group. It's no longer needed. But I did use this. I used the enter data. Well, I started out using the enter data approach, but that has a limit of 3,000 cells. So if I look at the stores one, basically I brought in the data from a CSV and then use this hack to get around that 3,000 cells limit where, I'm converting the previous table to JSON, taking the text from that, compressing it, and then taking the text from that, and then basically copying, pasting this as the source for these hard-coded things. So these are the ones that matter, but there's no source to these. It's all hard-coded, pasted text in there, that compressed data. So you can delete this one and everything just comes from those. And the parameters tell you basically how many of that hard-coded table to use in the sales table and then in the loaded table. So there's a loaded products table, a loaded stores table, and then the sales one is where all the magic happens. And so basically it starts out by bringing in the product table, the number of rows that you specify in the that are open or closed given the range start and range end parameters. That's why it's a max count. And then, cross join that basically with the store table, and then eventually cross join that with the dates. So between the range start and range end, the list of dates is generated, and use that. And then there's another filter here that takes care of, make sure that the store was open and the product was launched, for example, when that sale occurred. So there's a store and a product filter. Then I add an index and then use list.random. And I won't go into the logic here, but I had to work this out, how to come up with the right seed parameter so that I didn't see sort of annoying patterns in the data. And so this is what I came up with to add the quantity. The unit price is brought in with the product table, so I just multiply that so it's pre-calculated in the table. And then brought in, I mentioned that the product and the stores have sort of a volume adjustment factor that I randomly assigned, but are now hard coded in. This combines those and then basically uses another quote randomly generated list with a seed term to decide which rows to keep or delete. That's just referring to the previous step there. And then I added basically if that value is below or these randomly generated numbers, and it gets a 1 or a 0, and then I filter out the ones. So at the end of the day, I think it keeps about 40% of the data so that we get some interesting differences between stores and products. So you have to load more data to get the target number of rows that you want. Then in a similar approach, loaded a quote random return date, you should get the same one every time with the same parameters, and then finally load the sales table. So this was a fun exercise. So even though you don't need to worry about the Power Query side, it maybe interests people to go through and maybe you could come up with a better way to do what I'm doing here, or a more performant way. That would be great. But you don't need to worry about the Power Query side, but it's there if you're interested. And like I mentioned before, there is also a date table on the M side. So that's there in case you want to use it to try things out with dealing with dates and stuff in Power Query, or you can choose to load that and delete the DAX table. Either way is fine. So I think that's all I wanted to share. Again, leave comments below if you do play with this. I'd like to continue to make it better if it's useful to others. If not, I'll keep using it for myself, and that's fine too. All right, thanks.